Section 2. How computers see images learning objectives. By the end of this section, learners will be able to 1. Explain that computers don't see pictures the way humans do. They see numbers. 2. Understand the concept of pixels as the building blocks of digital images. 3. Recognize how computers process colors, brightness, and patterns mathematically. 4. Appreciate the difference between human vision, rich, meaning-based, and machine vision, data-driven. Now that we know what computer vision is, let's look at how it actually works at the most basic level. How do computers see images? For us, looking at a photo of a cat feels simple. We instantly know it's a cat, maybe even the breed, color, or emotion in its face. But a computer doesn't see cats, flowers, or people. Instead, a computer sees an image as nothing more than numbers. Images as grids of numbers. A digital image is really a grid of tiny squares called pixels. Each pixel holds numbers describing its color or brightness. Imagine zooming in on a picture until it looks blocky. Those small blocks are pixels. In black and white images, each pixel is just a brightness number. 0 is black, 255 as white, numbers in between 8 shades of gray. In color images, each pixel has 3 numbers, red, green, blue, that mix to produce a color. So when you look at a cat photo, the computer is seeing something like this. 0, 120, 245, 100, at yours, 255, 255, 255, thousands or millions of numbers. That's how a machine sees, by processing numerical patterns of pixels. From pixels to patterns. Of course, raw numbers don't mean much on their own. This is where algorithms come in. The computer examines how pixels are arranged into shapes, edges, textures, and colors. For example, sharp changes in brightness may mean an edge, like the outline of a cat's ear. Clusters of similar patterns can be recognized as features, like fur texture, whiskers, or eyes. Slowly, by analyzing these patterns, the machine can start piecing together what the image represents. Analogy: seeing without meaning. Think of a friend who doesn't speak your language looking at a book. They see the letters and shapes, but don't understand the words. Similarly, a computer sees the pixels, shapes, and colors first, and only later learns to associate those with meaning like cat, tree, or stop sign. Human vision versus computer vision. Human vision. Rich, intuitive, fast. We see meaning instantly. That's my friend's face. Computer vision. Cold, numerical, step by step. First sees pixels, then edges, then shapes. Eventually assigns meaning based on trained patterns. Neither is better, just different. Humans excel in common sense, but computers excel at processing millions of images consistently without fatigue. Reflection. Take a photo on your phone and zoom in as far as possible until the image looks like little colored blocks. Can you imagine how a computer might see just those pixel values? How is that perspective different from the way you just know what the photo shows? Key takeaways, 1. Computers don't see images like humans. They see grids of pixels, which are just numbers. 2. Pixels capture brightness, black and white, or colors, red, green, blue values. 3. Algorithms detect patterns in pixels, and edges, textures, that build up to recognition of objects. 4. Humans see meaning instantly. Computers build meaning step by step from raw data. 5. Pixel-based vision is both limited, machines lack intuition, and powerful. They can process massive datasets at high speed.